Good morning, everyone. Thank you for joining us today. I'm going to talk about Agentic AI and how you scale Agentic AI applications in your enterprise with NVIDIA solutions on Azure. My name is Matheen Raza. I work in our enterprise products team at NVIDIA, and I work on AI products and services that we then enable with our partners such as Microsoft to help our customers build Agentic AI solutions for their enterprise workloads, right? So before I start, how many of you are wondering what is NVIDIA doing talking about software and Agentic AI software? Raise your hands. How many of you are wondering about? There you go. At least, yeah. Okay, quite a few of you. I was on the show floor yesterday, and I got a lot of questions around this. So I want to talk a little bit about what NVIDIA does and how why we are here talking about software solutions for Agentic AI. Of course, we build. NVIDIA is an accelerated computing company. We believe in accelerating workloads with our GPUs, but it's not just the GPUs that we provide. Right? We have GPUs, our networking, our system software, and additional libraries and software that we provide to allow our enterprise customers to build. We provide basically the building blocks that allows our customers and partners to build solutions around that accelerated computing solutions for different workloads. What we typically do is we look at additional workloads and we figure out how can we accelerate these workloads. So we build libraries around accelerating those workloads, and then as those solutions mature, as they become more viable in the market, we build productized solutions around that. So in most of my presentation, I'm going to talk about the productized solutions that we provide for Agentic AI workloads. I want to give a few examples. Right, this just came out. We made an announcement with Snowflake where we are using NVIDIA CUDA-X libraries to accelerate data science workflows for Snowflake customers. So Snowflake just launched Snowflake ML, and Snowflake ML uses cuML, which is an accelerated computing library that allows users to run libraries such as PyTorch, scikit-learn on GPUs and accelerate those workloads. So we are able to bring performance benefits to these workloads by helping them run on GPUs. And we integrate with Snowflake, so the Snowflake users get this benefit with this integration. cuDF is an acceleration for data frame, right? It allows users to run pandas, libraries such as pandas and scikit-learn again, which are essential libraries in the data science workflow, to run them on GPUs. So we bring this acceleration and allow GPU acceleration to traditional machine learning workloads as well. And now, with this integration, Snowflake customers get to experience these benefits as well. But it's not just the libraries layer, right? These integrations are down to the hardware level, to the networking level. It's a co-engineered solution. We understand how these workloads utilize the hardware, and we optimize the libraries so that they are able to take the full advantage of the hardware that's available to them. So in this example, we just announced this performance benchmark at GTC, which was just a couple of weeks back, with a mixture of experts model and the GB200 NVL72. So the NVL72 is not just a set of GPUs, but it's 72 GPUs that are connected together so that they act as a single GPU. They connected together with high-speed networking. So the optimizations go down to that hardware level, to the networking level, to make sure that all these GPUs are able to move data between them very efficiently. And then the libraries take advantage of those hardware innovations to then bring those performance benefits. So now having seen these performance improvements, which we view as a success, as an early indicator of success, we will then take this and implement this in open source projects such as Dynamo, which will eventually get to products such as NIM to bring that optimized inference to our enterprise customers as well. Now, so this is the context in which we're talking about Agentic AI software and the work that we're doing with our partners such as Microsoft and other partners who are building solutions for their end users. And across the board, right, with Agentic AI, we are seeing how this is transforming how we are working every day. Right? We ourselves, many of us are experiencing this in our day-to-day lives, where certain things that we do are just being done much faster and more effectively with the use of Agentic AI. And Just a few examples here, right? DataStax was able to ingest documents 10 times faster for their customer Wikimedia. Another great example is ServiceNow, which was able to accelerate disputes management by up to 30% for their end customer Visa. So they used our software and implemented a solution that was then allowed Visa to accelerate a particular business function and gain productivity benefits out of that. Finally, a really cool example that I want to call out is VAST, that worked with NHL to ingest 500 petabytes of data, video data, and then analyze that, index that data, and then be able to search on that data and identify a specific video clip. For instance, in the demo that we showed with VAST, they were able to find a clip from a Stanley Cup like in 1992 and find me a clip of such and such person raising the Stanley Cup, and it was able to go and find that from all the archive video that NHL had. And I have a couple of cool examples when it comes to video search and summarization that which is what VAST based that blueprint on, and I'll share that through this presentation. So this presentation is a mix of slides. I'll show you some video demos. So hopefully it'll be not just a set of slides that I'm going to talk about, but I'll show you how these things come together in products and how some of our partners are building products around this. Now, having talked about what partners do, we ourselves at NVIDIA, we are using agentic AI in our day-to-day lives, right, in our day-to-day work. And a couple of examples of that is for chip design, where we have something called Chip NeMo, which is basically a large language model that is trained on chip design data. So it's trained on chip design data, so it understands the design files, the design configurations, and then we implemented a bug remediation workflow that was able to, because it understood our design documents, it was able to provide this remediation much faster. So something that would have taken an engineer several hours to debug and fix, provide a resolution to, Chip NeMo would do it in a matter of minutes. Thus, on average, we've seen across 5,000 engineers, we were able to save, with productivity gains, we were able to save about 4,000 engineering days a year by the implementation of this. So we ourselves are using this to accelerate the stuff that we do. Another great example is CVE remediation for software engineering. If you're using open source software will every now and then have vulnerabilities, and there's a database that exposes, publishes these vulnerabilities. And usually it is the job of an analyst to go and review these, figure out which code is impacted by these vulnerabilities, then identify a fix, and then fix that, push that through. We implemented a workflow with agents where the agents would read this database, identify the different pieces of code, because now it understood your code, your entire code tree, and identify the pieces of code where this vulnerability will be exposed or could be exploited, and then identify a fix and implement create a pull request for that fix. Something that would take an analyst multiple days, a day to multiple days, is done in a minute, and you have a human in the loop who can then review that and either approve it or not approve it. Another one that is a really cool one that I really like, and I use it on a regular basis, is a deep research assistant. And I've got a demo on that. This is, this deep research assistant essentially has access controls to the different tools I would have within the enterprise, and I can go and ask it to complete a task for me. It's able to look at the relevant files, or I provided additional files, and then summarize and create a report for me. Like if I were to do every now and then I have to go and do an industry analyst report, what are market trends, I could use this and then summarize that, and it creates a report for me. So I'm going to show this. This is a demo that we had in one of our shows. I'm going to show this. It does not really show this in action because I cannot show you any confidential files that it reads. But in this case, we're providing it a set of files, and it creates a report for us based on, you'll see it. I'm going to play this demo for you now.
Agents have joined the global workforce. AI agents have joined the global workforce. NVIDIA IQ, an agentic AI blueprint, lets enterprises connect AI agents to reasoning models and data systems. Given a task, Agent TJ needs to reason, plan, iterate, and use tools to generate a final report. For example, what if I want to research information for a board brief? IQ uses NIM and NeMo to help TJ synthesize hours worth of research in minutes. llama Nemotron Super lets TJ reason and has the capability to switch its reasoning functionality on or off, a single multi-purpose model. When on, the model can find the best answer faster than other similar reasoning models. NeMo Agent Ops Tools helps TJ process information, adapt, and learn. It can ingest petabytes of data faster with world-class semantic query accuracy. NeMo curates user and AI feedback, then post-trains small models to exceed the accuracy of larger ones for greater efficiency. With the IQ Blueprint, developers can unlock the full potential of AI agents.
So there's a couple of things that you saw there. And let me talk about what, at a high level, at a super high level, how these agents work. Right? There's a couple of things that you saw there. You gave it a query, but the agent was then able to go and understand what the query is. It has this understanding of, okay, this is what the user has asked me. These are the tasks I need to perform. So once it understands that, the agent is then able to go and plan what it needs to execute. So in this case, in the example that we showed, the only additional thing outside of the files that we provided, it went and ran a web search. But you could configure an agent to run any tools within your enterprise. For instance, if you need to access a structured database, I think the block diagram showed SAP and another bug database, so you could access the bug database. So right now, internally, the way we've implemented it is you can access a Jira. So if I need to search for information in Jira files, let's say I'm looking for product feedback, I could go and create a query there, and it'll go and pull information from that database and summarize it for me. So one of the things with the model is that the model has this long thinking time, right? It goes through multiple iterations. You saw that it went through multiple iterations before it provided the output. So from a compute standpoint, you're seeing multiple passes on the model, right? Multiple inference queries, and then it's storing larger context as well. It's storing larger documents, and it's able to have a conversation with you. So if you see the chat interface, it's not just a one-shot response. You can have an interaction with it, ask it to go and redo the responses. So there's longer context that is storing. And this is important. So based on how this agent works, how we saw this agent operating, here are 3 key requirements, right? 3 key requirements and how we are addressing these key requirements. This is how we view it. We need reasoning models that can understand the query, iterate upon themselves, and then provide the right response. And then optimize inference. As these models are taking multiple turns, you need to make sure that your inference is performance optimized, you have throughput and latency optimized, so that you maximize the infrastructure that you're running on, and thereby minimize costs and maximize your TCO. Or minimize your TCO, sorry. And then orchestration, right? Once you're using these models, you want to provide these models with your enterprise context. Right? You want to make sure that they understand the language of your enterprise. So how do you do that? Right? Then there needs to be a mechanism to do that, a process to do that. And I'll talk about some of the tools that we are bringing out to the market that help with this. Let's talk about reasoning models. So while we have several leading frontier models, we understand that from an enterprise standpoint, building a lot of enterprises require models that have a diverse expertise. It's not just a general purpose model. You want models that are specialized. You just don't want a model that's graduated high school. You want a model that's specialized and has a PhD in a particular domain. So you want highly accurate models. And this is what drives the needs for specialized, customized models from our customers. And then the understanding that these models have to be trained on commercially viable data. The data sets, enterprises need to have an understanding of how these models were trained, what data sets they were trained on, and if they want to need to go and repeat that process, they need to have the visibility to do that, if they choose to do that. Right? And then tools in order to fine-tune the models as well. And then at the same time, when the model is deployed, it needs to be deployed in an efficient manner, so it's efficiently using your compute resources. And this is why we built Nemotron. And if you've not heard of Nemotron before, Nemotron is it's a family of models that we build. And these are open weight models. So we publish these models on Hugging Face. You can download these models. You can view the weights of these models. So as open as they get. And then these models, we have the data sets that we use to train these models, and additional data that we've used to fine-tune the model, we share this. In addition, we share the recipes, the methodology that we use to distill these models. Some of these models are based on large language models such as Llama, so we show these recipes on how we fine-tune these models. So we publish these recipes as well. So if anyone chooses to do so, they can go and fine-tune these models themselves. They can, in fact, replicate the entire process to train the model, and they can rebuild it if they choose to do so. And Nemotron has not just, and this is where I was talking about specialized models, is not just the large language model, it's a variety of different models. Even in the large language models, we've got different flavors of these, depending on what you're trying to trade off. Right? If you want an efficient model, we have the nano models. If you want a highly accurate model, we have the ultra model. Vision language models are super popular, especially Nemotron Parse, which is able to extract multimodal data from your PDF documents. The information retrieval, Nemotron RAG, is an embedding and retrieval model, so it is able to extract this information, vectorize it, and then retrieve it in a RAG pipeline. In addition, we have additional models that provide this content safety, Nemotron safety models, and then we also publish the models that were used to train these, the data sets that we use to train these models. And our models perform really well when compared to similar open source models. In this case, we're comparing it with a Qwen2 model, and across different functionality from coding, from scientific reasoning, math processing, understanding graduate level understanding of certain topics, these models perform really well. And that's why I'm here talking about these models, because we are really confident of these models, and these models are really popular with the partners and the customers that we're working with. Now, while these models are great, we talked about optimizing the inference runtime as well, so making sure we deploy these models in an efficient manner, reducing throughput latency and maximizing the infrastructure that we're running it on. And this is why we have, many of you must have heard of NVIDIA NIM microservices. These microservices include some of the infra level, library level optimizations that we do to make sure that the models run with the best possible, the most optimized performance. And in addition, what we do with the NIM is that we patch these security vulnerabilities on a regular basis, right? So anytime you're using open source software, as I said, there could be vulnerabilities, and we monitor these and we patch these for you on a regular basis so that you don't have to go and monitor these and maintain these. And then we provide this API stability. We continuously monitor, we patch, and make sure that the containers are enterprise ready like you expect it to be. Now I have a short demo on the performance of NIM. It's a quick one that we did with one of our startup partners who deployed their application with NIM and without NIM, and did this comparison. So the NIM-off is just an open source model model runtime that's downloaded, and a DIY approach to building that model. Whereas with the NIM, with all the optimizations, you can see that the query is already done. And in this case, we're seeing about a 6x improvement in latency, but typically it's anywhere between 1.2 to 2x that we'd see an improvement in latency on average. So these NIM, we work with Microsoft to upload these models to Microsoft Foundry, formerly Azure AI Foundry. So NIM models are available on Azure AI Foundry. In addition, you can use a standard Kubernetes environment to deploy these, so they deploy on AKS, but you can stand up your own model as an endpoint in Azure AI Foundry. Now, this is an integration that I want to highlight. We just announced this through a blog yesterday, and this is where our models integrating with a Microsoft service, and then you get to utilize this inside that Microsoft service. So this is exactly the kind of how we want our models to be used, right? It's accelerating a specific function that you will do within Microsoft. So in this case, SQL Server is launching some new capabilities to generate embeddings within SQL Server. And on the back end, we've configured it to use use our embedding model as a NIM deployed on Azure. On Azure clouds, it's deployed on Azure Container Apps, but you could stand it up on Azure AI Foundry as well. In this case, for the reference architecture, we chose to deploy it on ACA. At the same time, if you have SQL Server running on-prem, you could do it on Azure Local as well. You could do it in a Kubernetes environment in Azure Local. So you get that same model, same consistency across these two different environments. Right? So if you're operating in different environments, this is something to think about. And you get that functionality you implement that functionality with SQL Server. Now, having talked about how inference, let's move into some of the tools that we need to fine-tune models. Or building an agentic AI application requires not just the model, but additional microservices that go with the model. So I'll talk a little bit about the tool sets and the frameworks that we provide to fine-tune these models as well. So why do you need to fine-tune, right? Some of the things that are true with something that is very data intensive as your agentic AI application is that data ages rapidly. It changes rapidly, and then it ages rapidly because you're constantly, how your users interact with your application, they're generating new data, and that data is actually changing the original knowledge set that you've trained your model on, or you've trained your agentic system on. So you need to continuously monitor that and have a framework to be able to retrain these models or retrain these systems. And then if you look at the framework ecosystem to build models, there's multiple different frameworks. The different teams could be using different frameworks based on the use case that you have in place. And you have to have a way of connecting with these different frameworks. Not just different frameworks, but also different systems within your enterprise. You need a standardized way to connect to your enterprise knowledge sources. And your customers' needs are evolving. How your customers use this could change, and as a result, what you do with this application, how you tune this application will also change. And of course, we don't like to highlight this at NVIDIA, but with the reasoning models, right, the inference cost is growing. Right? These are long thinking models, the inference cost is growing. So you have to have a way to monitor this and find places where you can optimize the performance. Right? And at the same time, you want these, as you move to more critical workloads to extract more value, the accuracy is going to be super important for your models. It has to be spot on when it comes to accuracy, and you need to be able to monitor that accuracy and fine-tune the model on a regular basis so that it is within that guardband, especially for really sensitive applications, right? It's very different from a support chatbot to something that is making a diagnosis on a patient, right? So you have to be super accurate for some of these applications. And this is where the NeMo framework, the NeMo set of microservices and the tooling comes in play. So we have on top is NeMo Agent Toolkit, which is a SDK. It's a toolkit to build models. It is a framework agnostic toolkit, so it can connect to additional toolkits, additional frameworks such as LangChain, Crew AI, multiple different frameworks, and be able to connect to those models or agents that you've built in those frameworks. So if somebody in your organization has built with LangChain, you can build a NeMo Agent Toolkit, and you can connect to that agent in a standardized interface. And then NeMo microservices, you have from Data Designer, Safe Synthesizer. Data Designer really generates synthetic data, like based on your enterprise data. It learns from your enterprise data, and you don't have this set of data. It'll create additional data, and this is safe data that is built on your enterprise data that you can then use to fine-tune your model. So your model understands, or your agent understands, the language of your enterprise. And Safe Synthesizer is a way for you to mask PII information and sensitive information from the data that you're using for training. Customizer customizes the model, and you have evaluator, and then guardrails to set some bounds around your model. And then these are available as API-first microservices. And whereas if you have researchers and developers who really want to find, build their own runtimes for these services or incorporate it into additional functionality that they're building, they can use the frameworks and the toolkits to build it themselves. Now, I talked about different building blocks, right? I'm sure a lot of you are wondering, how does this all come together, right? So we do something we call blueprints to bring it all together in terms of reference applications. Right, so blueprints are, think of it as a software reference architecture that we published with the sample code, with the sample data. You can deploy it with a simple Helm chart, and it's modular enough that you could replace certain components. Like, for instance, if you take our RAG blueprint and you don't want to use that vector database that we've got in there, you can replace that vector database. Some of our partners have done that. They've taken out the vector database, they've implemented their own vector database, and since it connects through the standard API, they're able to do that. So I'm going to talk about a couple of blueprints, and I have a cool demo on the video summarization functionality, and then I will wrap it up. So I want to talk about the deep research. This is the demo that I showed you earlier. This is how a high-level architecture of the deep research blueprint. What you see in the bottom there that says RAG, that is actually another blueprint. We have a blueprint, the foundational RAG, we call it the foundational RAG blueprint. And it shows you how to build an enterprise knowledge retrieval pipeline. It extracts information from your PDF files, whether the information is in tables, charts, images. It's able to read all of that, vectorize that, and then provide it to the model during retrieval. And in this case, we're using a reasoning model that is then able to additionally run a web search if necessary and collect this information, aggregate this information, summarize it, and provide it back as a report or a simple summary, depending on the prompt from the user. So this is the workflow we've actually implemented in that video that I showed earlier. The deep research agent that we've implemented internally is based on this blueprint. And we've had several partners who've actually implemented solutions based on this blueprint. Like, one of our storage partners implemented a support agent for monitoring their storage systems and providing automated remediation based on this blueprint. So another cool blueprint that is really very popular, and this is a testament to the video modality these days being really popular. We're collecting large volumes of data these days, and I'm not just talking about TikTok videos, but we have instrumented and wired up our entire world, and we're collecting this feed, right? And we're monitoring a lot of different locations. At the same time, we're collecting a lot of different feed that we want to get intelligence out of this video. How do we utilize this video? Whether it's a sports event, whether it's monitoring security at a music concert, we want to be able to get actionable insights and take action on those insights that we get from these videos, on that intelligence that we get out of these videos. And this is the high-level block diagram. What I'm really trying to show here is we have a visual agent here, and we have not just the large language, the text modality models, but we also have models that are really popular these days, the visual models, the models that understand our physical world. This includes our VLM models, this includes some of our Cosmos Reason models, if you've heard of that. Cosmos Reason models is models that understand our physical world. And the rest of this is standard and non-NVIDIA stuff. It's either we've implemented with open source technology or with partners that we've collaborated with. And at the end of it, it can summarize, allow you to ask Q&A, set up alerts, identify certain triggers within the specific video. So I'm going to show this demo next. So this is built on our what we call our video search and summarization blueprint. And when I mentioned earlier VAST and the NHL, this was what they built their use case on. This has no voice. Maybe it does. Oh, it does, just a little bit. But it's able to extract analytics out of a sports game. So all that you see is data analytics that it's extracting out of it. And here it's identifying a specific traffic event. a safety implementation here. Again, this is within the workflow, whether the right steps are followed. In this case, an obvious step was skipped, and it's highlighting that. Again, warehouse safety, this is a key use case for a lot of our customers who are doing digital things like digital twins. This model gets used there a lot. Okay. This video goes a lot longer. It's available on our website. There's a lot of interesting things in there. I just cut it short for this purposes. Okay, so finally, to wrap it up, we provide the building blocks for Agentic AI. We provide the models, we provide the toolkit and the microservices that you need to build out Agentic AI applications, and we pull it all together into blueprints to show you sample applications that you can then use in your workflow as a starting point. You don't have to go and figure out every single step. You look at that as a reference architecture. It's modular enough that you can pull out pieces and replace it with pieces that are more suitable for your enterprise, but it gives you a great starting point. And if you're a partner who's working as an SI with additional customers, you can use that to build out additional solutions, which a lot of our partners have done. And that's the end of my talk. And if you're interested in learning more about any of the things that I shared today, we have a website called build.nvidia.com. I thought I listed it here, but it's build.nvidia.com. And you can learn more. That's our learning page. You can go there and learn more. We also have a developer program, a very popular developer program. You can sign up for a developer program to get access to our models, get access to some of the software that we are building, and start building your applications, figure out how you can bring Agentic AI into your enterprise. Thank you so much for your time, and I'll be around here if you have any additional questions. Thank you.